All right. So I think I'm recording now. Yes. Moving on. All right. Suppose a business owner wishes to rank the top 3 of 5 locations. So once again, we're doing permutation. Permutations, order matters. So we need to know order matters. When we do permutation, order matters. So when you rank something, it's important to be ranked. It matters. First place, second place, third place. Do you see rank is when you rank something, the order matters. The order matters at what you put things in. So we have 5 locations, location A, B, C, D, E. But we have 5 locations, but we want to rank the top 3. First place, second place, and third place. How many different ways can we rank these? How many different locations can I put in the first spot? Unmute and yell it. How many different locations can I put in the first spot? We have 3 spots we have to rank. We got to rank the best location. How many locations can I put in the first spot? Or how many locations do I have to choose from to put in the first spot? And the answer is there are 5 locations. If I use that location and say, oh, that location is first place, then I only have 4 locations left. And after that, I only have 3 locations left. So these 3 locations were ranked in the top 3 out of the 5 locations that we had. So this is 120. Seems like all our answers are going to be 120. Don't trust that on the test. So there are 120 different ways of ranking 5 locations in 3 spots. Well, let's write that. That's a permutation. Permutation order matters. We have 5 locations, and we want to rank them in 3 spots. This is 5. This is our total number, and these are the 3 spots where order matters. So if you put that in your calculator, 5P3, 5 math permutation, which is number 2, hit enter and then hit 3. Did I type in? Oh, I did the math wrong. How come nobody yelled at me? I get 60. 5 times 4 is 20. 20 times 3 is 60, not 120. Are you guys just agreeing with everything, or you're not even paying attention? Are you guys there? Anybody there? Just say hello.
Hello.
Okay.
Hello.
I just want to make sure you guys are here. Nobody's yelling at me. Nobody's checking my work. All right.
It's too much effort to unmute the computer and then remute it.
All right. Yeah, I'm not buying that. All right. So to pick, if you have 5 locations, dude, I'm still trying to get there. If you have 5 locations and you need to pick 3, and the order matters, because we're ranking them. Ranking order matters. You get 60. All right, this bottom one, a radio talk show host has to select 3 spots from 6 guests. So they have 6 guests, but they only have 3 spots to put these guests on. The order of the appearance of the guest is important. That means the order matters. when it says it's important, they're going to rank them. The order matters that you put the guests in. Oh, I can only go first if I'm going to be on the radio, you know, so they'll say something like that. So order matters. If it's order matters, it's a permutation. We keep on talking about permutation, but there's another one we're going to talk about, combination, in a little bit, where order does not matter. So it's important to understand the ones that matter. It tells you the order of appearance of a guest is important. The order matters. So it's a permutation. Since it's important, the order matters, it's a permutation. We have 6 guests total. The highest number always goes on the left. And we have to select 3 spots for them on the radio. So we're going to put this into our calculator. 6P3. 6, math, arrow over, go down to permutation, which is number 2. Hit enter and hit 3. And this one equals 120. You guys better check my work.
That's correct.
Good, thanks.
Yeah, it's 120.
There we go. So permutations, order mattered. And I mean, I would write that down somehow. It's really important that permutation order matters. We actually have a quiz about that here in a little bit. I think this week or next week, an online quiz in Canvas. So this next problem, a school musical play, a musical director has 2 plays to present next year. So they're going to present 2 musical plays. One is in the fall and one is in the spring. She has 9 to pick from. Now, how many different possibilities are there? Now, does order matter? This is actually a tough one. Order does matter here because we have a fall play and then we have a spring play. You see, if they didn't label these spots, then it wouldn't matter which play you put first or second. But you have a fall play and you have a spring play. There are certain plays that you should only do in the fall, I guess, and certain for the spring. But since they labeled each of these spots, the order matters. We want a fall play and we want a spring play. So once again, this permutation order matters. We have 9 total plays to pick from, but we're only going to pick 2 of them. So on our calculator, we're going to do 9, pick 2. 9, permutation, math, arrow over, pick 2. And out of the 9 plays, there are 72 different possibilities of arranging those 9 plays. So 9P2 equals 72. All right. All right, permutation rule number 2. So this rule is only good if you have repeating, if you're going to arrange letters. So you might, because this is definitely on the test, it's definitely on the final exam. This rule is arranging letters. This rule is only when you arrange letters, and that's why they call it letter permutation rule. It's n factorial. N is the total number of letters. Total letters. It's not letting me write. And the bottom is the R factorials. Repeating letters. How many repeating letters do we have in each category? And I'll show you what I mean. How many permutations of these letters can be made from the word statistics? So first we have to count the number of letters. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 letters total. Do you see that's the top? Total letters. Now, are there any repeating letters?
Yes.
Look at the S's. The S's repeat. We have 3 S's, so we put 3 factorial down here. The T's.
3.
1, 2, 3 T's. So we put 3 factorial down here, and we're going to multiply it, by the way. These are all multiplied together. Any other repeating letter? We only have 1 A. Oh, we have 2 I's. Do you see we have 2 I's? I should use a different color for I's. It's getting kind of messy. So we have, 1, 2 I's. So we put 2 factorial for I's. 1 C, 1 A, and that's it. We don't have to put 1 factorial for something that doesn't repeat. So we just have to put the stuff that repeats more than once, because times 1 is still 1. So on our calculator, we need to do this. Oh, you better be careful about this one. So let's see if we can put this on our calculator. Let's see if I can put this on my calculator. I want to try to make it bigger. There should be a way for me to make it bigger right away for me. So on my calculator, we're going to do 10 math arrow over permutation. 10 factorial. What am I talking about? We're doing 10 math number 4. 10 factorial divided by, now the bottom it has more than one thing to do. So since we have more than one thing on the bottom, you have to put that entire bottom in a parentheses. You have to put that entire bottom in a parentheses. So divided by parentheses 3 factorial times 3 factorial times 2 factorial. And close the parentheses. So I put that all in a parentheses. 10 factorial divided by 3 factorial times 3 factorial times 2 factorial. And when I hit enter, I get 50,400. So there are over 50,000 ways to arrange the letters in statistics. Everybody okay with that? So you have to do the factorial, the total letters factorial on top, divided by repeating, how many of each repeating letter multiplied on the bottom. When you do that bottom, make sure that bottom is in parentheses when you put it in your calculator. 10 factorial divided by 3 factorial times 3 factorial times 2 factorial. By the way, 3 factorials, 3 times 2 times 1 is 6. You could have just said divided by 6 times 6, and 2 factorials, 2 times 1 is 2. So you could have did 10 factorial divided by 6 times 6 times 2. It's the same thing. Anybody else get that answer?
I got a same one.
Good, good. So sometimes it takes a little bit to type it in correctly. All right, so now the word combination is coming. We write combination similar to factorial, except we use a C in the middle instead of a P. Remember, permutation order matters. A combination, the order is not important. The order doesn't matter, not important. Because in combination, you're not ranking people. Instead of saying, I want the top 3 runners, you just say, I want 3 runners. So if you want 3 runners, it doesn't matter which 3 you get because you're not looking for the top 3. So the order is not important. So combination, order is not important. Let me show you, they wanted to show you this. This is this right here is a permutation of A, B, C, D when you choose 2. If we have 4, and by the way, try this. Do you see? I'm going to choose 2 letters. Choose 2 letters from 4. We have 4 letters, A, B, C, D. So on your calculator, do 4, math, permutation, 2, and, except I typed something wrong. 4, math, permutation, 2, and I get 12 different ways of arranging these letters. And sure enough, if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there are 12 ways of arranging these combinations when the order matters. Do you see? Here A is first, here A is second. The order matters. A is first or second. This is called order matters permutation. Now, I think it's below this, but I want to put this side by side. Combination, the order doesn't matter. So if we have an AB, we don't need a BA. Do you see? Because BA is the same as AB. The order doesn't matter. So for combination, if you have an AB, you can't have a BA. AB, AC, AD. Well, we already have a AB over there, or a BA. BC, so we don't have a B. If I'm looking at the BC now, we don't have a C and a B, or a B and a C, or a B and a D, or a D and a B. CA, I'm looking at this one now, we already have that. CB, we have that. CD, oh, we don't have a CD or a DC, so CD is on here. DA, I don't see a DA or an AD. And BD, there's a BD here, DB and DC, DC. So I see AB, BC, oh wait, I wrote down AB twice. AC, AB, BC, BD, CD, and DA. These are all the same over here, except the order doesn't matter. AC is the same thing as CA and AC. Do you see it represents 2 over there. So we have 6 numbers. Try this on your calculator now. 4C2. We're picking 2, the same as we did for permutation over here, the same as we did for permutation. We're picking 2, but the order doesn't matter. If I have an AC and a CA, it counts as 1. So 4C2, 4, math, probability and combination is number 3, and then hit 2. And do you see for combination, there are only 6 possibilities. We have 6. 1, 2, 3, 4, 5, 6. There are only 6 possibilities. For permutation, there are 12 because the order matters. Who comes first and who's second. For combination, it doesn't matter who's first or who's second. So that's kind of important. So let's take a look. And by the way, sometimes on the test, it's not going to tell you which one to use. So you may have to use the one yourself. And here they just showed about combination. This is the formula for combination. Well, you see it's the same as permutation, except for the added, it's the exact same thing as permutation. This is permutation. They just added an extra R factorial on the bottom. So AB is the same thing as BA, so you don't count that twice. So how many combinations of 4 objects are there taken 2 at a time? We have 4 objects. It says combination, and we're going to take them 2 at a time. And we just actually did that one. You should get 6. 4, math, arrow over, NCR, picking 2, hit enter, and you get 6. So a combination, you always have less possibilities for a combination. 4P2 is 12. Do you see when you use P, you get a higher number because order matter, you can do 1 AB or B or BA. For combination, you get a smaller number than you would for permutation. All right, so let's take a look at some of these problems. And advertising exec must select 3 different photographs from a flyer. Must select 3 different photographs for an advertising flyer. She has 10. She has 10, and we're gonna pick 3. So we could do it like this, or we can do it like that. One of these is correct. So you're picking 3 from 10. How many ways can she select 3 of them? 3 different photographs from an assigning an advertising flyer. Now, does it matter which pictures you pick? Do they say it matters?
No.
Yeah, they don't tell you. So this one, the order matters. This one, the order matters. This one, they don't say the order doesn't matter. So this is the one we're going to use. Order does not matter. They don't mention which one is the top one. We want to pick the top 3. Well, that means the order matters if you're picking the top 3. Here, we're just picking 3. So we're doing this as a combination. So we're typing in 10, math, arrow over, number 3 is combination, and we're picking 3 of them, and I get 120 ways. It does seem like our answer for 120 happens a lot. Don't trust that on the test. All right. Next one down here. In a club, there are 7. Oh, this is going to be a little bit harder. I need a little extra room. It's not really harder, but it's a little different. In a club, there are 7 women and 5 men. We need a committee. of 3 women and 2 men. So we need 2 committees of 3 women and 2 men. Now, when I pick the 3 women, by the way, it's 7 women total. And we're going to pick 3. Here we have 5 men total, and we're going to pick 2. How many different possibilities are there? It doesn't say which women, the women, it doesn't say that the order matters. We're just picking 3 women. It doesn't say we're picking the smartest 3. It doesn't say we're picking the tallest 3. So we're just picking 3. Order does not matter. If you're just picking 3, order does not matter. So if order does not matter, we're using a combination. So here we got 7 and we're picking 3. Here we have 5 men and we're choosing 2. Just like before, we're going to find this number of choices and then we're going to multiply it with this number of choices because we're picking 2 separate categories here. First, we're picking women and then we're picking men. So on my calculator, I'm going to actually type both of those in. I'm going to hit second math, or 7 math probability combination 3 times 5 math combination 2. So if you see on my calculator, I typed it in all at once. I think, did I? Oh, I didn't hit 2. Hopefully this works. Let's see what happens. Anybody else get 700?
I got 350.
Okay, so I think I did something wrong. Let me look at my calculator.
Yeah, I got 352.
Okay, I think I hit 2 twice, I think. Let me try this again. 7 math, combination 2, unless I hit probability by accident, times 5 math 2. I'm not even getting anything close. I got 200 and, oh, I still typed it in wrong. Oh, man. 7 math 3 times 5 math combination 2. And finally, 350. Yay. Okay, good. Thank you. So you should have got 350. When we did this. So there are 350 possibilities of picking 3 from 7 women and 2 from 5 men. All right. Let's see where we're going now. Here's all the rules that we've had so far, all the formulas. We've had the fundamental counting rule for, like, if McDonald's serves 3 burgers, 2 sizes of drink, 3 sizes of French fries, how many different possibilities can you get? Then we have permutation rule where order matters. Order is important. The permutation rule, NPR, oh, there it is. Then we have this one is the arranging letters, the total letters divided by repeating letters, how many times they repeat. And then we have combination, order does not matter. So that was 4.4. Definitely look at the homework assignments for that. You should look at the homework assignments for everything. There is a quiz, and I'm going to look at that before we leave. There is a quiz on that, and that quiz will help you pick whether it's a combination or a permutation. I think it's a really good quiz, and it's going to help you whether it's a permutation or a combination. All righty. Let me hit. Give me a second here. I hit stop recording.